Did that work?
Yeah.
Okay.
Hello, everyone. Welcome. We had the task of presenting scanning electron microscopes. And with me are
Armando,
Chris,
Lex.
and me, Chandler. All right, so first we have to start off with the basic principles and how we actually know how scanning electron microscopes actually work, or SEM for short. It has the ability to magnify things up to 500,000 times, while the compound is under the microscope and can be magnified 1,000 times. It's only possible by using a light source that is an electron beam, as opposed to the common ones that you see in regular labs. And the microscope, those microscopes uses light with wavelengths in the visible spectrum, where the SEM does not. And the electrons, they have a shorter wavelength than the visible light, so they're able to produce a higher resolution image.
So just a quick overview on the components of the SEM. First of all, at the top, we have the electron gun. So basically, this is just a piece of metal that's heated and accelerates electrons into a beam. This is the source of, not the light, but this is the source of the beam of electrons, basically. Then we have the anode, which attracts the electrons, so it ensures that the electrons are all going in the same direction. The anode, as you can imagine, has a positive charge and brings the electrons towards it. Following that, we have a series of magnetic lenses, which not only accelerate, but also focus the electron beam into a very tight diameter. Finally, we have our detectors. We have a backscattered electron detector, which gives topographical data. And then we also have a secondary electron detector, which gives slightly different topographical data. And finally, we have the stage, which, as for every microscope, holds the sample.
awesome. So now we're going to be speaking about the electron gun, which is the first component. This produces a source of electron and accelerates it to an energy range of about 1 to about 40 kilo electron volts. The beam diameter is very large, so you can see in the initial picture, which needs lenses so that way it can reduce the beam and be more focused. So the electron beam that's actually emitted onto the specimen surface can be less than about 10 nanometers, very tiny. And through the lenses, of course, which we'll be speaking next, there's a lot of variations in current, size of the source, stability of the emitted current, and the lifetime of the source as well that can change the image. And then we have the actual magnetic lenses. As you see this one in this diagram, it has 2 of them. The condenser lens, which actually accelerates the electron beam, sort of brings it together. And then the objective lens, which actually focuses the beam. So the electrons emitted from the electron gun need to be focused into a tight beam. Then that's, of course, what the lenses are for. The SEM utilizes 2 of them, which can actually focus the beam from about 1 to 1,000 nanometers. And then, of course, the 2 would be the condenser lens and the objective lens that are used.
Now we move on to the detectors. The first one is a backscatter electron detector. This is the first detector that detects anything from the sample. It detects right below the surface, so it gets the closest electrons, and it has to have the highest energy electrons as well because it's the closest from the source. Now the secondary electron detector, it's further away, and it could intercross with the backscatter in a middle section between the 2, and it detects from further back, and it has a higher resolution, I believe.
Okay, so here is a visual comparison of the side scatter and back scatter images. So on the left, you see, on the far left is the side scatter, in the middle is the back scatter, and finally, when you compound the 2 images, you get a more, I guess, sharper image of the topographical data.
now the stage, it's what holds the sample. It's a basic metal platform that's aluminum for the, and it moves around to be rotated to get the full 360-degree image of the sample. And the sample on it, it's just the dry sample in resin. So it won't have like any interference from anything else but the sample.
Okay, so as far as imaging is concerned, basically the way it works is the incident electrons interact with the specimen, and then the atoms are then scattered. The electron signal is then recorded by a detector, and the signal is photographed using a CCD camera typically, or for older models, actually film is used in order to generate the image. Now, the image formation requires the scanning system to create an image point by point. So essentially that electron ray that's been focused creates maybe one point at a time, and then eventually it's compounded into one whole image. And then finally the beam has a scattered relationship with the specimen as opposed to a linear relationship.
In applications, why would a lab want to purchase one of these machines? Is it can characterize any solid material. So like we mentioned previously, it gives you an image of a topographical, morphological, and compositional information regarding the sample itself. So it has a lot of applications in the environment and then other analytical labs as well. And then it also shows the different surface fractures. So if you have a sample, let's just say a sand sample, you can actually see how defined the edges are or how undefined the edges are. And then it can reveal any spatial variations of chemical composition, so quality control, things like that. And that can be used for qualitative chemical analysis. And it could also identify any crystalline structures, again, for qualitative analysis. Lastly, for organic materials, you can use it for cell morphology, and it can be used for intracellular and bacterial interactions. And then advantages and disadvantages. One of the advantages is it's very versatile. So it can find a home in many different labs. I mentioned environmental lab, at a bacteria lab, and even chemical industry labs. So very versatile in operation. It's also a fast operation as well. You take the image and then you should get the information relatively quickly versus other different microscopes. And it's very cost heavy upfront. And what that means is it costs a lot to start, but when it actually is maintained, then there's very minimal preparation to actually use the SEM machine. Now, some of the disadvantages is, like I mentioned previously, it requires a lot of upfront costs. And another disadvantage is that you need some training for it, and it's a specialized tool.
And just like Chandler said, the cost there, you can get one of these puppies for $82,000, and this isn't a new one either. So the older model, $82,000 for this specific one, as you can see on the bottom left picture.
Mm-hmm. And then just some of the references that we had. So this actually came from a distributor. So that's where I got some of the information for the advantages and disadvantages. And
then the remainder of the information was used through a textbook written by the writers there, which is called the Scanning Electron Microscopy and X-ray Microanalysis. So it's a text for biologists, material scientists, and geologists.
All right.
Thank you.
Let's see. You got it. It's right here. Oh no, that's just no. You gotta stop. Sure. Stop right now. Stop right now. Okay. All right. We're good. All right. Yeah, we're good. All right. Wait, no. I need to click it. No.